have to discuss those quantization and atomic stability and atomic stability. So we have Gauss quantization rule means. So that a nice book is defining that whenever electron which are moving, that is having an angular momentum. Now this angular momentum of a particle is equal to, it is an integral multiple of h by 2 pi is equal to integral multiple of h by 2 pi. So this is called as Gauss quantization rule. The Gauss quantization rule is given by whenever any particle is under motion, then it is having an angular momentum. Now this angular momentum is equal to an integral multiple of h by 2 pi. So that angular momentum is given by integral multiple of h by 2 pi is h by 2 pi is called as L. So this is called as an integral multiple of h by 2 pi, in which n takes the value, it is an integer, where n is equal to an integer. So maybe it is 1, 2, 3, up to like this. So this is called as Gauss quantization rule. Now we have to do this Gauss quantization rule by taking a simple harmonic oscillator. So we know that a simple harmonic oscillator, since it's a simple harmonic oscillator, it is a simple harmonic oscillator. So we have to show, we have to prove that angular momentum is equal to an integral multiple of h by 2 pi by taking the simple harmonic oscillator as an example. Imagine we have a simple harmonic oscillator. This is a simple harmonic oscillator. This is having a mass is given by m. Since the simple harmonic oscillator which is under motion, so whenever a simple harmonic oscillator which is under motion, it gets displaced. It gets displaced through a distance of x. Simple harmonic oscillator is that. The simple harmonic oscillator is under motion. Then whenever it is under motion means it is having an oscillator is having a mass m, and it gets displaced. So whenever it is under motion means there will be some capacity of doing work. The capacity of doing work by the virtue of its motion of any particle. So like this, the capacity of doing work by the virtue of its motion of a simple harmonic oscillator, that is called as kinetic. This kinetic energy is given by half mv square. Isn't it? So here, kinetic energy of a simple harmonic oscillator is given by half mv square. So here, mv square has a mass of an oscillator, is called as velocity of an oscillator. Here, we are taking that oscillator gets displaced to a distance of x. Whenever displacement is x, then this harmonic oscillator is moving through some distance displacement x in time t. In time t, time t seconds x ಅಷ್ಟು displacement ಆಗಿದೆ. x ಅಷ್ಟು displacement time t ನಲ್ಲಿ ಆಗಿದೆ. Now we understand that velocity of the simple harmonic oscillator is given by dx by dt. Is given by dx by dt. So displacement x on the velocity dx by dt. So whenever velocity is equal to dx by dt, then kinetic energy is given by half m. So dx divided by dt whole square. energy of a simple harmonic oscillator is given by kinetic energy is equal to half m dx by dt whole square. Since this is called as a simple harmonic oscillator, it is moving like this. So these are called as extreme points. So the point this is called as an extreme position. So here it is called as an extreme position. So you have to call an extreme position. Extreme position. So the simple harmonic oscillator, which is moving like this side, again is coming to this side. This is called as center. Again is moving like this. Again. So that means it is moving like this. So whenever a simple harmonic oscillator move in that fashion, whenever that simple harmonic oscillator which is moving to the extreme position, then that energy of this oscillator goes on decreasing. So extreme position ಹೋದಂಗೆಲ್ಲ ಆ kinetic energy of a simple harmonic oscillator ಹೋಗ್ತಾ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ extreme position ಹೋದಾಗ ಕಂಪ್ಲೀಟ್ ಇಲ್ಲ. ಸೊ ಆಗಲೇ again ಈ ಕಡೆ ಬರ್ತಾ ಇದೆ, ಈ ಕಡೆ ಹೋಗ್ತಾ ಡಿಕ್ರೀಸಿಂಗ್ ಆಗ್ತಾ ಇದೆ ನೋಡಿ. ಸೊ ಆಗ ಈ ಕಡೆ ಹೋಗ್ತಾ ಡಿಕ್ರೀಸಿಂಗ್ ಆಗ್ತಿದೆ. ಸೊ whenever it is moving like this, so that the kinetic energy of a simple harmonic oscillator goes on increasing. Again it is going to this point. This point is called as equilibrium position. So this is called as equilibrium position. So ಯಾವಾಗ equilibrium position ಬಂದ್ಬಿಡ್ತೋ ಇಲ್ಲಿ ನಮಗೆ kinetic energy will be maximum. The kinetic energy of a simple harmonic oscillator is maximum at the equilibrium position. Again ಈ ಕಡೆ ಬರ್ತಾ ಇದೆ. So again ಈ ಕಡೆ ಬಂದಾಗ ಇದು ಕೂಡ totally here it is a kinetic energy goes on decreasing. It means that kinetic energy of a simple harmonic oscillator is maximum at the equilibrium position. So kinetic energy of a simple harmonic oscillator is maximum at the equilibrium position. So whenever we have the kinetic energy of a simple harmonic oscillator is maximum means we have to say that this is called as the maximum kinetic energy. So the maximum kinetic energy is given by half m dx by dt whole square. Since in the beginning we are telling that, so imagine we have a simple harmonic oscillator. That oscillator is under mass m and also it is moving to a displacement x in some time t seconds. ಯಾವಾಗ ಒಂದು ಟೈಮ್ t seconds ಅಷ್ಟಕ್ಕೆ ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ x ಅಷ್ಟು ಮೂವಿಂಗ್ ಆಗಿದೆ. Then the equation for the displacement of a simple harmonic oscillator is given by we are saying that x should be equal to a sin omega t. So this is the displacement of the simple harmonic oscillator when it is moving to a displacement of x some time t seconds. Now the x displacement is given by a sin omega t. So here we know that omega is given by 2 pi nu. That's why I said that x is equal to a into sin into in the place of omega you have to put 2 pi nu into t. So x is equal to a sin 2 pi nu into t because here omega is called as angular velocity. That angular velocity is given by 2 pi nu for a simple harmonic oscillator. That's why x is equal to a sin 2 pi nu into t. So that is called as equation number 1. Then equation number 1. Equation number is an expression for the displacement of a simple harmonic oscillator. Simple harmonic oscillator ಎಷ್ಟು displacement ಹೋಗಿದೆ in some time t seconds ಅದಕ್ಕೆ. This is the equation for the displacement moved by a simple harmonic oscillator. That x is equal to a sin 2 pi nu into t. And also here a is called as that amplitude. A is called as the amplitude here. Nu is called as frequency. In this equation, x is called as the displacement, a is called as amplitude, and we have 2 into pi, and also nu is called as frequency, t is called as time. So that x is equal to a into sin 2 pi nu into t. That's equation number 1. And as I told in the beginning, is given by kinetic energy is equal to half mv square. That's why kinetic energy is equal to half into m into dx by dt whole square. So that the kinetic energy of a simple harmonic oscillator is maximum at the equilibrium position. That's why we have the maximum kinetic energy of a simple harmonic oscillator at the equilibrium position is given by half m dx by dt whole square. So now m is called as mass of the oscillator and v is called as velocity of the oscillator. So from the equation number 1, let us imagine this is called as equation number 1. Let us have to differentiate this with respect to time. Whenever if we differentiate this with respect to time, then we say that dx divided by dt. Because here dx by dt is here in the equation. We want to find one equation, one value for this dx by dt. So that's why we know x. If we differentiate this x with respect to t, definitely we will get the value of dx by dt. That the value of dx by dt can be substituted in this equation. Okay. So because of that, differentiating this x with respect to time t. So whenever dx by dt is equal to a as it is. Okay. The differentiation of sine 2 pi ut is given by cos 2 pi ut into d by dt of this one is given by 2 pi u. So this is called as the differentiation of displacement. So dx by dt is equal to a into cos 2 pi ut into 2 pi u. So finally we have to say that is given by, so 2 pi u a 2 pi u a 2 pi u into a 2 pi u a into cos 2 pi u t. This is given by dx divided by dt is given by 2 pi u a and cos 2 pi u t. So at equilibrium position we have that dx by dt is maximum. So at equilibrium position we have dx divided by dt is maximum. So whenever dx by dt is maximum, then we have that the maximum value of cos 2 pi ut is equal to 1. So if the maximum of the cos 2 pi ut 1 we have a dx by dt is maximum. That's why the maximum value of cos 2 pi ut is equal to 1. Therefore dx divided by dt, dx by ut is equal to cos 2 pi ut is to factor of 1 into 2 pi ua. It becomes 2 pi ua. So the maximum value of dx by dt is equal to 1. So it is complete to 1 1 into 2 pi ua, 2 pi ua, that is given by dx by dt. So this is dx by dt is equal to 2 pi ua is a maximum value of dx by dt. So therefore we have said that dx by dt maximum should be equal to 2 pi u into a. So whenever then by making use of this equation, kinetic energy maximum is equal to half into m into dx by dt ಇದೆಲ್ಲ ಈ ಇದನ್ನು 2 pi u ಎಂದು ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ತೀವಿ. So we have that is kinetic energy maximum. Therefore we have kinetic energy maximum means maximum kinetic energy is given by half into m into 2 pi u a. And then I go 2 pi u a, it is given by whole square. Okay. So this is called as maximum value of the kinetic energy at the equilibrium position. Now kinetic energy maximum is given by half m 2 pi u a whole square. So ಇದನ್ನ ನಾವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡೋಣ ನಮಗೆ therefore kinetic energy maximum is given by half into m into 2 pi u a whole square. So now the maximum kinetic energy, that the maximum kinetic energy of that oscillator at the equilibrium position is the total energy of the oscillator. ಏನು equilibrium position ಅಲ್ಲಿ this is called as equilibrium position ಎಲ್ಲ. So at this equilibrium point we have that energy should be maximum. This maximum energy of the oscillator at the equilibrium position is nothing but total energy of the oscillator. ಅಂದ್ರೆ ಈ ಮಧ್ಯಭಾಗ ಬಂದಾಗ ನಮಗೆ ಏನು maximum kinetic energy ಇದೆಯಲ್ಲ, that is nothing but total energy of the oscillator. Now we have to say that total energy is given by, therefore total energy is given by, here we have to say that total energy is given by, total energy is given by, so we have to say that total energy is total energy is given by half into m into 2 pi mu a, as it is there 2 pi mu a whole square, half into m into 2 pi mu a whole square. So ಇದನ್ನು ನಾವು ಮಾಡುವಾಗ ನಮಗೆ so ಇಲ್ಲಿ 2 into 2 4 ಆಗ್ತಲ್ವಾ, 4 divided by 2 we have only 2, so we have 2 pi square mu square a square m. So this is 4 by 2 2, again pi square mu square a square and we have a m. Now the total energy of the oscillator, simple harmonic oscillator, is given by 2 pi square mu square a square m. Now according to quantum condition, according to quantum theory, so we will have that energy should be an integral multiple of h by 2 pi. So according to quantum theory, the total energy is equal to integral multiple of h by 2 pi. This is according to quantum theory. According to quantum theory, we have total energy is given by as an integral multiple of h by 2 pi. So we call the also in terms of frequency node is an integral multiple of h nu in terms of frequency node. So integral multiple of h nu. Therefore, this is called as total energy. Total energy means this one, 2 into pi square into mu square into a square into m. This is called as total energy. Total energy equals to total energy is equal to somewhere other 2 pi square mu square a square m. That is given by h nu, because integral multiple of h is h nu. So 2 pi square mu square a square m is given by h nu, but it is integral multiple. That's why we have to put 1 n here. Okay, so 2 pi square mu square a square m is equal to n into h nu. See, after this we will have, and therefore here we have one thing, 2 pi square h. Okay, so we'll have 2 pi square mu square a square m is equal to, here we have n is equal to 1. N is an integer, that's why I have to put n is equal to 1. So 2 pi square mu square 2 pi square mu a square m is equal to nh. Okay, so here we have nh, 1 u get cancels, then finally we have 2 pi square mu a square m is equal to n into h. So let us consider equation number 2. This is called as equation number 2. So here that Px is momentum of the oscillator. The momentum of the oscillator. So then Px is given by m into Vx by dt. So momentum is given by the product of mass and velocity. Here, whenever x is the displacement, so we have dx by dt is called as velocity. That's why the momentum is given by m into v. here is dx by dt. That's why dx is equal to m into dx by dt. So after this, that is given by m into the value of dx by dt. The value of dx by dt ಗೊತ್ತಾಗಿದೆ ಮೊದಲ್ವಾ ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡ್ತೀವಿ. So m into 2 pi mu a 2 pi mu a 2 pi mu a cos 2 pi mu t. So this is given by dx by dt. Okay, dx by dt value is there. Okay, so it is 2 pi mu a and cos 2 pi mu t. Okay, so now we have to multiply all these things. That gives us momentum. Okay, here put m into 2 pi mu a. M into 2 pi mu a is equal to b. So m into 2 pi mu a ನಾವು b ಅಂತ ನಾವು ಇಟ್ಕೊಂತೀವಿ. So b ನ ಇಟ್ಕೊಂಡಾಗ then finally now dx is equal to complete interval b ಆಗುತ್ತೆ. So we have b cos 2 pi mu t. So this is momentum is given by b into cos 2 pi mu t. See after this we have to say that px divided by b is equal to b ನ ಕೆಳಗಡೆ ತಗೊಂಡ್ರೆ so px divided by b is given by cos 2 pi mu t. Cos 2 pi mu t. So let us also have equation number this by b is given by equation number 3. So this is equation number 3. Okay, right. From equation 1. Equation 1. This is called as equation number 1. From the equation number 1 we have a the current now is x by a. X by a. Isn't it? X by a is equal to we have sin 2 pi mu t. Sin 2 pi mu t. Sin 2 into pi into mu t. Okay, this is from equation number 1. We have x by a is equal to sin 2 pi mu t. That is also equation number 4. We have equation number 4 the number consider. See now we have to square and add equation number 3 and 4. So equation number 3 na equation number 4 na square ಮಾಡಿ add ಮಾಡ್ತೀವಿ. Square ಮಾಡಿ add ಮಾಡಿದಾಗ we will get x squared by a squared divided by a squared. Left hand side square ಮಾಡಿದಾಗ ಇದು square ಮಾಡಿದಾಗ we have p squared by px squared divided by p. ಅದಲ್ವಾ ಇದನ್ನ ಸ್ಕ್ವೇರ್ ಮಾಡಿ ನೋಡಿ ಸ್ಕ್ವೇರ್ ಮಾಡಿದ್ವಿ ಮತ್ತೆ ಆಡ್ ಮಾಡಿದ್ವಿ ಆಡ್ ಪಾಸಿಟಿವ್. So now what is after square and adding equation number 3
1
ಎಷ್ಟಾಗುತ್ತೆ equation 1 ಆಗುತ್ತಲ್ವಾ ಹೇಗಾಗುತ್ತೆ 1 ಹೇಗಾಗುತ್ತೆ 1
cos square theta plus sin square theta is equal to 1.
fine good super. So ಅದನ್ನ ಆಡ್ ಮಾಡಿದಾಗ ನಮಗೆ ಅದನ್ನ cos theta 2 pi u ನ theta ಅಂತ ನಾವು ಇಟ್ಕೊಂತೀವಿ ಅಂದ್ಕೊಳ್ಳಿ. ಹಾಗೇನೇ sin 2 pi u ಅದು theta ಅಂತ ಅಂತೀವಿ. sin square theta plus cos square theta is equal to 1 ಅದಲ್ವಾ. So ಅಲ್ಲಿಗೆ so will have that it is given by this 1. So we get one equation ನೋಡಿ x squared by a squared plus px squared by b is equal to 1. This is one famous equation. ಅದನ್ನ ಯಾವ equation ಅಂತ ಹೇಳ್ಬೋದು ನಾವು. What is the name of that equation? ನಾಲ್ಕು ಇದೆ ನಿಮಗೆ x squared by a squared plus ಒಂದು ಹೇಳಿದ ನಮ್ಮಲ್ಲಿ px ಅಂತ ಇದೆ ನಾವು ಮೊಮೆಂಟ್
ellipse.
Good, fine. So this is an equation for the ellipse. This is an equation for the ellipse. So this is an equation for the ellipse. Okay. So ಈಗ ಆ ಕಡೆ ನಾವು ಇದನ್ನ ಕಂಟಿನ್ಯೂ ಮಾಡ್ಲಿಕ್ಕೆ ನಿಮಗೆ ಬೋರ್ಡ್ ಕಾಣ್ತಾ ಇಲ್ಲ. ಈ ಕಡೆ ಅಳಿಸ್ಬಿಡ್ಲಾ? ಇದರಲ್ಲಿ ನಿಮಗೆ ಡೌಟ್ ಇದ್ರೆ ಕೇಳಿ ನೋಡೋಣ. ಏನೋ ಡೌಟ್ ಇದೆಯಾ? ಯಾಕೆಂದ್ರೆ ಆ ಕಡೆ ಬಲಭಾಗ ನಾವು ಹೋದಾಗ ನಿಮ್ಗೆ ಬೋರ್ಡ್ ಕಾಣಿಸ್ತಿಲ್ಲ. ಈ ಫಸ್ಟ್ ಇದನ್ನ ನೋಡ್ಕೊಳ್ಳಿ. ಇದರಲ್ಲಿ ಸಪೋಸ್ ಇಫ್ ಯು ಹ್ಯಾವ್ ಎನಿ ಡೌಟ್ ಇನ್ ದಿಸ್ ಯು ಕ್ಯಾನ್ ಆಸ್ಕ್ ಮೀ ಬಿಕಾಸ್ ದಿಸ್ ಇಸ್ ಅನ್ ಇಂಪಾರ್ಟೆಂಟ್ ಒನ್. ಓಕೆ, ದಟ್ಸ್ ವೈ ಐ ಆಮ್ ಟೆಲ್ಲಿಂಗ್. ಸೊ ಆಮೇಲೆ ಈ ಕಡೆ ನಾನು ಅಳಿಸ್ತಾ ಇದ್ದೀನಿ. ಫಸ್ಟ್ ಪಾರ್ಟ್ ಇದೆಲ್ಲ ಅಳಿಸ್ತಾ ಇದ್ದೀನಿ. ಅಳ್ಸಕ್ಕಿಂತ ಮುಂಚೆ ನೀವು ಒಂದ್ಸಲ ಚೆಕ್ಅಪ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಸೊ ನಿಮ್ಗೆ ಏನ ಡೌಟ್ ಇದೆಯಾ ಅಂತ. ಬೇಕಾದ್ರೆ ಇದೊಂದು 2 minutes ಇನ್ನೊಂದ್ಸಲ ನಿಮ್ಗೆ ಅದನ್ನ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿ ಹೇಳ್ತೀನಿ ಬೇಕಾದ್ರೆ, ಹೌದಲ್ವಾ? ಈಗ ನಾವೇನ್ ಮಾಡಿದೀವಿ ಅಂತಂದ್ರೆ ಫಸ್ಟ್ ಸ್ಟಾರ್ಟಿಂಗು ಒಂದು ಲೀನಿಯರ್ ಸಿಂಪಲ್ ಹಾರ್ಮೋನಿಕ್ ಆಸಿಲೇಟರ್ ನಾವು ತಗೊಂಡಿದೀವಿ. Let us consider a linear simple harmonic oscillator, and also x be its a displacement. That oscillator is under motion, then under motion it will have some displacement. So now x anna displacement anna ತಗೊಂಡಿದೀವಿ at any instant of time. Then the equation for the displacement x is equal to a sin omega t, that is equal to a into psi. In the place of omega we have omega is called as angular velocity. In terms of frequency na ತಗೊಂಡಾಗ angular velocity is given by 2 pi nu agutte. So that's why we have to say that x is equal to a into sin 2 pi nu t. That is called, that is equation number 1. So in this equation a stands for amplitude and nu stands for frequency. ಇದೆಲ್ಲ ನಿಮಗೆ ಗೊತ್ತಾಗಿದೆ. Next, that kinetic energy of the oscillator at any instant of time t is given by, and the oscillator is under motion. So whenever oscillator is under motion, there will be some capacity of doing work has to be taken. Okay. Now this capacity of doing work by the virtue of its motion is given by kinetic energy. That's why that kinetic energy is given by half mv squared. So here v is called as linear velocity of the oscillator. So whenever v is called as velocity, then the x displacement on the mele velocity is given by dx by dt. That's why in the place of v we are substituting the dx by dt. It means that kinetic energy is given by half m into dx by dt whole squared agutte. And again we know that m is called as the mass of the oscillator, and v we know that is a linear velocity. Now from the equation number 1 ನಮಗೆ ಅಲ್ಲೇನು dx by dt whole squared ಅಂತ ಇದಲ್ವಾ, ಆ dx by dt whole squared ಗೆ ನಾವು ತಗೊಂಡಾಗ ನಮ್ಗೆ ಅಲ್ಲೊಂದು ಈಕ್ವೇಶನ್ ಬೇಕಾಗುತ್ತೆ. ಅದನ್ನ ಈಕ್ವೇಶನ್ ನಂಬರ್ 1 ಅಲ್ಲಿ ನಾವು ತಗೊಂತಾ ಇದ್ದೀವಿ. ಸೊ ಈಕ್ವೇಶನ್ ನಂಬರ್ 1 which tells us dx by dt is equal to a into cos 2 pi nu t into differentiation of that internal term is given by 2 pi nu. So finally it is given that dx by dt is equal to 2 pi nu a into cos 2 pi nu t. So at equilibrium dx by dt is maximum. Equilibrium alli dx by dt maximum agutte. The maximum value of cos 2 pi nu t is equal to 1. So therefore cos 2 pi nu t 1 anta ನಾವು ಇಟ್ಟಾಗ that dx by dt maximum is equal to 2 pi nu a. Therefore maximum energy, maximum kinetic energy ke maximum is equal to half into m into dx by dt maximum whole square. So this maximum kinetic energy of the oscillator at the equilibrium position is nothing but is the total energy of the oscillator. Therefore that the total energy is equal to half into m into 2 pi nu a whole squared, that is equal to 2 into pi squared nu squared a squared m agutte. Now according to the quantum condition, energy should be an integral multiple of h and nu. That's why here that energy means it is called as total energy. It is given by 2 pi squared nu squared a squared m. That is nothing but integral multiple on the nh nu. It is called as nh nu, where n is called as integer. Therefore 2 pi squared nu a squared m is equal to nh, because one nu in a nu cancel agide alli. Let us imagine this is called as equation number 2. Here now let whenever that oscillator is having a velocity means there is that momentum is also comes into existence in the case of oscillator. That's why we are taking that let px be the momentum of the oscillator. Then px is equal to mass into velocity. ಇಲ್ಲಿ velocity is dx by dt. That's why px is equal to m into dx by dt. That is equal to m into dx by dt ಗೆ ಮೇಲ್ಗಡೆ ನಮಗೆ ಆಲೆ ಒಂದು ಈಕ್ವೇಷನ್ ನಾವು ಡಿಫರೆನ್ಸಿಯೇಷನ್ ಮಾಡಿ ಇಟ್ಕೊಂಡಿದ್ದೀವಿ. ಅದನ್ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಮಾಡಿದೀವಿ 2 pi nu a into cos 2 pi nu t. So here let us put m into 2 pi nu a is equal to capital B. Therefore px is equal to b into cos 2 pi nu t agutte. Now px divided by b is given by cos 2 pi nu t. Let us call equation number 3. So from the equation number 1 we got x by a is equal to sin 2 pi nu t. Let us call that as equation number 4. Now after square and adding equation 3 and 4, we will get x squared by a squared plus p squared divided by b squared is equal to 1. It is the equation for the ellipse. Here a ellipse and x time ಮುಗಿತಾ ಬಂದ್ರೆ ನೆಕ್ಸ್ಟ್ ಮಾಸ್ಟರ್ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಮಾಸ್ಟರ್ ವೆಯ್ಟ್ ಮಾಡ್ತಾ ಇದಾರೆ. ನೆಕ್ಸ್ಟ್ ಎಲಿಪ್ಸ್ ಇನ್ನ ಒಂದು ಫಿಗರ್ ಹಾಕೊಂಡು ಅಲ್ಲಿ ಎ ಅಂದೇನು ಬಿ ಅಂದೇನು ಎಕ್ಸ್ ಅಂದೇನು ಪಿ ಅಂದೇನು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ನಾವು ಅದನ್ನ ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ. ಓಕೆ, ಸೊ ದಟ್ ಇಸ್ ಐ ವಿಲ್ ಟೇಕ್ ದ ಅಟೆಂಡೆನ್ಸ್ ನೌ.